Hello, and welcome to this presentation on factor theorem. This method allows us to solve equations of the form function of x is equal to x cubed plus x squared minus 4x minus 4 using a trial and error method. Factors and roots of polynomial expressions. There's a simple relationship between the factors of a quadratic expression and the roots of the equation, which are obtained by equating the expression to 0. Example 1. If we're asked to solve the quadratic equation x squared plus 2x minus a is equal to 0, then this equation can be solved using the factorization process we've looked at in previous presentations. So given the expression x squared plus 2x minus 8, we're going to find factors of this. The factors are x minus 2 in a bracket multiplied by x plus 4 in a bracket. If we were to expand this back using our binomial expansion technique, we would end up with the original expression given here. So now we can equate these two factors in their brackets, x minus 2 and x plus 4, to 0. Now, if the product of two numbers is 0, then one or both of the numbers must equal 0. So for example, either the x minus 2 factor is equal to 0, which would give us a value of x is equal to 2, or the x plus 4 factor equals to 0. And again, if we subtract 4 from both sides of the equation, we get x is equal to negative 4. So what we can say here is that the factor of x minus 2 equates to a root of x plus 2. And also a factor of x plus 4 equates to a root of x is equal to negative 4. These roots are shown on the graph on the following slide. Example 1 continued. This is a plot of y is equal to x squared plus 2x minus 8. So we can see that when we have a factor of x minus 2, that equates to a root of x is positive 2 over here. If we have a factor of x plus 4, then that equates to a root of x is equal to negative 4, which is this root here. And the roots are the solutions to the equations. So therefore, in general, we can say a factor of x minus a equates to a root of x is equal to positive a, or x is equal to a. Factor theorem. In practice, it's usual to determine the roots of a simple quadratic equation from the factors of the quadratic expression, as in the example above. However, this factorization process could be reversed. If by trial and error it is found that x is equal to 2 is a root of the quadratic equation x squared plus 2x minus 8 is equal to 0, it could be stated that x minus 2 is a factor of the expression x squared plus 2x minus 8. Quadratic equations would not usually be solved in the method shown on the previous slide, but suppose a cubic expression, that's a polynomial where the highest power of the variable is 3, has to be factorized. A cubic equation could have 3 simple factors, and the difficulty of discovering all of the factors by trial and error could be immense. So to aid solution of this type of problem, factor theorem is often used. So factor theorem provides a method of factorizing any polynomial in the functional form fx, which has simple factors. In most cases, that will mean that the factors contain whole numbers. So factor theorem states if x equals to a is a root of an equation function of x is equal to 0, then x minus a is a factor of the function of x equation. Do note though that factors theorem cannot be used to solve expressions like sine of x minus sine 45 degrees. Factor theorem does not work for that kind of trigonometric expression. Example 2. We're asked to factorise the expression x cubed minus 7x minus 6 and use this to solve the equation of x cubed minus 7x minus 6 is equal to 0. Notice this is a cubic equation, so there will be three factors to factorise this equation. So let's first write the expression in functional notation. So function of x is equal to x cubed minus 7x minus 6. We're going to use a trial and error approach here, the factor theorem, to find the first root. But notice the hint here, we're going to be selective in our trial and error approach. We're going to consider first of all the divisors of the constant negative 6. So in other words, the numbers that divide completely into negative 6. So that would be 1, 2, 3 and 6. They all divide completely into negative 6. But also we could try negative 1, negative 2, negative 3 and negative 6 because they again divide completely into negative 6. Let's try now a root of x is equal to 1 for our first attempt. All we do now is put the value of 1 into the function of x equation wherever we see an x. So on the left hand side that becomes function of 1, on the right hand side that becomes x cubed, so that's 1 cubed, minus 7 multiplied by x, so it's minus 7 multiplied by 1, minus 6, and that gives a value of negative 12. That doesn't equal to 0, so we have no factor here. Let's try x equal to 2. So function of x equal to 2 here, so put the value of 2 for x, that becomes 2 cubed, minus 7 multiplied by 2, minus 6. That produces a value again of negative 12. So again, that's not a solution, so there's no factor. Let's try x is equal to 3. Put the value of 3 for x in the function of x equation, we get 3 cubed, minus 7 multiplied by 3, minus 6. That does equal to 0, so we have found a root, so therefore we have a factor. Notice the factor now is x minus 3. So for a root of x equal to positive 3, the factor is x minus 3. So x equal to 3 produces a function of x equal to 0, so the x minus 3 is a factor from our factor theorem method. We can continue with the factor theorem to find the remaining two roots and so the remaining two factors. Just note, by inspection of the expression above, if we continue to use higher values than 3, we will not find another root as the x cubed term now dominates the expression for function of x and so will increasingly become larger than 0. So we need to try negative values of x, and that's what we will do on the next slide. Example 2, let's now try some negative numbers. Again, these are still divisors of the negative 6. Let's try x is equal to negative 2 for the root. What we do now is put the value of negative 1 for the x in the function of x equation. So on the left hand side it's function of negative 1 here. On the right hand side that would be negative 1 cubed minus 7 multiplied by negative 1 minus 6. Be careful with your evaluation there. When you cube a negative number it remains negative, but we've got a double negative here. We multiply negative 7 by the negative 1. Evaluating, we get a remainder of 0, so we have a root in this case because the answer is 0, so we have a factor. So the factor is x plus 1. So for a root of x equals negative 1, we have a factor of x plus 1. To try and find our third root, I'm going to use x equals negative 2, so again put in negative 2 into the function of x equation as before, and be careful of our negative numbers. We again find the answer is 0, so we have a root again, so we have a factor of x plus 2. Thus when x is equal to negative 1, the function of x is 0, so x plus 1 is a factor, and when x is equal to negative 2, the function of x is equal to 0, so x plus 2 is a factor. So the factors for this cubic equation, and there are 3 of them, are x minus 3, x plus 1, x plus 2, because the roots of the cubic equation were x is equal to positive 3, x is equal to negative 1, and x is equal to negative 2. I suggest you take a moment to reflect on the solutions shown on that slide and clearly understand the difference between factors and roots. Example 2 continued. This is the graphical approach here, and it shows you the roots. If you plot the curve y is equal to x cubed minus 7x minus 6, or a function of x is equal to x cubed minus 7x minus 6, you find there are roots at x is equal to positive 3, x is equal to negative 1, and x is equal to negative 2. Example 2 continued. So again, just to reinforce the point that all the roots of x that we found, the 3, the negative 1, and negative 2, are all factors of the constant term of the expression, or divisors, if you like, of 6. So a factor is any whole number dividing exactly into the given number in the expression. So for the trial and error process, we initially consider x values that are divisors of the constant. So factor theorem offers an alternative method to the factorizing of solving simple expressions, such as using polynomial division, something we're not covering in this presentation but covered in other presentations. Factor theorem can be used in conjunction with the polynomial division method and also the equating coefficients method, which is shown very briefly later on in the presentation. Exercise 1. We're asked to solve the cubic equation x cubed minus 2x squared minus 5x plus 6 is equal to 0 using factor theorem. I would strongly encourage you to attempt this question before reviewing the solution on the following slide. I suggest you refer to the solution shown in the previous example to show you how to structure your solution to this problem. Exercise 1, solution. We're asked to solve the equation x cubed minus 2x squared minus 5x plus 6 is equal to 0 using factor theorem. Firstly, let's write the above equation in terms of functional format. So function of x is equal to x cubed minus 2x squared minus 5x plus 6. And we're going to use the trial and error method, the factor theorem method, to find the roots and then find the factors. Note this is a cubic expression, x cubed, in the function, so there will be 3 linear factors for us to find. We're first going to consider the divisors of the constant 6 in the above expression, and those will be 1, 2, 3 and 6. They will divide completely into 6, but also don't forget we can try the negative numbers, negative 1, negative 2, negative 3 and negative 6. For the first trial we've used x is equal to 1 here. Don't forget all we do is put the value of 1 wherever we see an x in the function of x equation. So a function of 1 in this case, that will be 1 cubed minus 2 multiplied by 1 minus 5 multiplied by 1 plus 6. For a value of x equal to 1, we do get a remainder of 0, so straight away we've found a root, and therefore we found a factor. The factor is x minus 1. I'll let you review the following trials at your own pace. What you should find are the factors of the above expression are x minus 1, x plus 2, and x minus 3. And those were found from the roots in the above table of x is equal to 1, x equal to negative 2, and x is equal to 3. Your trials may be in a different order to that shown above for the x values, but that doesn't matter as long as you end up with the same 3 factors. Exercise 2, we're asked to factorise the quartic expression x to the 4 minus 5x squared plus 4. So we've got to solve the equation x to the 4 minus 5x squared plus 4 is equal to 0 using factor theorem. This is the quartic equation, x to the power 4, so there will be 4 roots to find here and 4 factors. Again, I would encourage you to stop the presentation and attempt this exercise before reviewing the worked solution on the following slide. Exercise 2, solution. We're asked to factorise the quartic expression of x to the 4 minus 5x squared plus 4 and hence solve the equation x to the 4 minus 5x squared plus 4 is equal to 0 using factor theorem. This is the quartic expression because of the power of 4 on the x. First of all, let's write this in function notation. So function of x is equal to x to the 4 minus 5x squared plus 4, and we're going to use the trial and error method, the factor theorem method, to find the roots and then find the factors. As we said, this is a quartic expression, so there will be 4 linear factors to find to factorise fully this expression. So let's now try a value of x. We're going to take x is equal to 1 for our first trial. Don't forget all we do now is put the value of 1 where we see an x in the above expression for function of x. So with the x equal to 1, that now becomes 1 to the power of 4 minus 5 multiplied by 1 squared plus 4. That does work out to be 0, so our remainder is 0. We've found our first root, so therefore the factor is x minus 1. I'll let you review the other trials in the table at your own pace. What you should find though ultimately is the factors of the above quartic are x plus 1, x minus 1, x plus 2 and x minus 2. And those are based on the roots in our table of x equals to negative 1, x equals to positive 1, x equals to negative 2 and x equals to positive 2. You may have attempted the x values in a different order and that's perfectly fine as long as you end up with the same 4 factors. Example 3 just shows an alternative way that the question can be worded. In this particular case we're asked to show that x minus 2 and x plus 1 are both factors of the cubic function of x is equal to x cubed plus x squared minus 4x minus 4. And we're asked to factorise the expression. So essentially what this example has given us are two solutions to the problem. It's given us the factor of x minus 2, it's given us the factor of x plus 1, and it's saying show that these are actually the factors of the expression given. So what we're going to do is check those in a moment to make sure that they do equal to 0. And then we finally got to find the third factor because it's a cubic expression, there will be 3 factors. So 2 are given, 1 we've got to find. So first of all, let's check the factor x minus 2. What we do now is put the value of 2 in the function of x equation shown above. So to check that the x minus 2 is indeed a factor, we should find that putting the root into the equation, so the root is x equals to 2, the remainder is 0. So in our function notation, function of the value of 2, on the right hand side that gives me x cubed, so that's 2 cubed, plus x squared, so that's 2 squared, minus 4 multiplied by x, so that's minus 4 multiplied by 2, minus 4 should equal to 0. And if we go through the numerical work, it does. So when x equals to 2, we have a root, so x minus 2 must be a factor. Now let's check the x plus 1 factor given in the example, make sure that is indeed a factor of the equation given. So all we do now is put the value of x is equal to negative 1 into our function of x equation. So function of negative 1 in this case, we'll get negative 1 cubed plus negative 1 squared minus 4 multiplied by negative 1 minus 4. Again, be careful here, when you cube a negative number it remains negative, but when you square a negative number it becomes a positive value. You've also got a double negative here to be careful of. But evaluating that correctly, we should find the remainder is 0. So again, we've shown that the x plus 1 is indeed a factor of the equation given. So now both x minus 2 and x plus 1 are factors of the equation function of x is equal to x cubed plus x squared minus 4x minus 4. However, because this is a cubic function, there will be 3 linear factors, so we need to find the third one. From inspection of the constant negative 4, the divisors are 1, 2, 4 and negative 1, negative 2, negative 4. As we have already used divisors negative 1 and 2 in the above solutions, I'm going to try negative 2 as my root. So put in the value of negative 2 for x in the function of x equation, so it's negative 2 cubed plus the negative 2 squared minus 4 multiplied by negative 2 minus 4. That does indeed come to a remainder of 0. So I've found the third root, which is x equals negative 2, so therefore the third factor will be x plus 2. So now all 3 factors are found. Example 3. This is an alternative method, and I wouldn't worry too much about this at the moment, but just to show you how an equating coefficients method could be used to find the third factor. The third factor is of the form x plus a. How do I know that? Well, because the x cubed term is basically 1x cubed in the equation, so there's a 1 there. So my third factor must be of the form x plus a, because the x multiplied by x multiplied by x, so that multiplied by that multiplied by that, must give me x cubed, because I've got 1x cubed in this particular case. So what we can do is to expand the brackets. Expanding the x minus 2 with the x plus 1 will give us x squared minus x minus 2, and then expanding that with the x plus a, we'll end up with this expression here on the right hand side. This is known as an identity. true for any value of x, and the coefficients must be the same on both sides of the equation. So what we're going to do is equate the coefficients of, for example, the constant term. So equating coefficients of the constant term, that's the pure numbers. So on the left-hand side of the equation, the pure number I have is -4, because the other terms have variables in them, they all have an x in them. But the -4 here is a constant value. So on the left-hand side I have -4. On the right-hand side, what are my constant values? Well, the only term without an x in it is the -2a. That's classified as a constant term. Now I could simply solve that equation for a by dividing throughout by -2, so a becomes 2. So my third factor is x plus 2. An alternative way of doing this would be to equate coefficients, say, of the x squared terms. So on the left-hand side, the coefficient of the x squared term is 1. We don't write the 1s, but there's a 1 there, so that's on the left-hand side. And on the right-hand side, the coefficients I have are -1 for the x squared term. Again, there's a 1 here we don't write. And also we have the a coefficient associated with the x squared, so I get my -1 plus a. Again, rearranging the equation, I can find that a is equal to 2. So again, the factors are x minus 2, x plus 1, and from above, x plus 2. That's an alternative method to using the factor theorem method, just for reference. Exercise 3, you're asked to show that x minus 2 and x plus 1 are both factors of the cubic function of x is equal to 2x cubed minus 4x squared minus 2x plus 4. We then got to find the third factor. I would encourage you to stop the presentation here and apply the method shown on the previous example to help you solve this problem. Firstly, you have to show that the x minus 2 and the x plus 1 factors are indeed factors of the function of x equation given. And then you have to find the third factor. Full solution shown on the following slide. Exercise 3, solution. We're asked to show that x minus 2 and x plus 1 are both factors of the cubic function given function of x is equal to 2x cubed minus 4x squared minus 2x plus 4. We're also asked to find the third factor. Don't forget it's a cubic equation, the x cubed there, so there'll be 3 factors. The first part of the solution checks out whether the factors given in the exercise are indeed factors of the cubic expression. So don't forget we'll be using the root there. So for x minus 2, the root will be positive 2. We simply put that into the above function of x equation and evaluate the remainder. If it comes to 0, then we found the root. And we do the same for the x plus 1 factor given in the exercise. That will be a root of x minus 1. And again, we should show that will be a remainder of 0. So we've shown that the 2 factors given in the exercise are indeed factors of the cubic expression. In the remaining part of the solution, we try and find the third factor. I'll let you review the solution at your own pace. What you should find ultimately are the factors are x minus 2, x plus 1, x minus 1. Exercise 3 continued. This is an alternative method to find the third factor using equating coefficients. So in this approach, we're going to have to let the third factor be of the form 2x plus a. So the question is, why is it 2x plus a? Well, in the expression given, the cubic term is 2x cubed. We've already found the factor of x minus 2 and x plus 1, so we'll need to multiply the x by 2x to produce the 2x cubed term. In other words, we're multiplying this x by this 2x to give us the 2x cubed term we're looking for in our expression. So 2x plus a will be the format of the third factor, a being a number, a constant. What we do now is expand the first 2 brackets, the x minus 2 multiplied by the x plus 1 produces x squared minus x minus 2, and then we multiply that by the 2x plus a bracket, and we get this further expansion shown here. This is what's called an identity, so it's true for any value of x, so therefore the coefficients must be the same on both sides of the equation. So we're going to use the equating coefficients method to find the value of a. And we can equate coefficients for the x cubed, the x squared, the x, or the constant terms. I'm going to use the constant term here. So on the left-hand side of the above identity, I have a constant of +4, so there's my 4 on the left-hand side, and on the right-hand side, the only constant I have is the -2a. All the other terms have an x in them, so they're by definition not a constant. So on the right-hand side, -2a is the term I use. Rearranging that equation, in other words, dividing both sides by -2, I end up with a is equal to -2. So my third factor is of the form 2x plus a, where the a in this case is -2. So my factor is 2x minus 2. If we want to find the root of that factor, we simply equate the factor to 0 and solve for x. So 2x minus 2 is equal to 0. If we add 2 to both sides and divide by 2, we find that x is equal to 1. So factors of the 2x cubed minus 4x squared minus 2x plus 4 expression are x minus 2, x plus 1, and x minus 1. And if we want the roots would be x is equal to 2, x is equal to -1, and x is equal to 1. But that's just showing you an alternative method to find the third factor. Here are some tutorial questions I would strongly encourage you to attempt. They all relate to cubic equations here. They've got an x cube in them, so there will be 3 roots and 3 factors to find. I would strongly encourage you to stop the presentation now and attempt these questions. The answers are shown on the following slide. Here are the answers for questions 1 to 5, questions 1, 2 and 3. The factors are shown, and in question 4 and 5 the roots are shown. Tutorial questions continued. Question 6, we're asked to show that the x minus 2 and the x plus 1 are indeed factors of the function of x expression shown in A and in B. And we're also asked to find the third factor in both cases. Question 7 is similar, except we are given the roots in this particular case to begin with and not the factor. We have to state all 3 factors in the solution. Answers are shown on the following slide. Here are the answers to question 6 part A and question 6 part B, and also to question 7. For your reference, here's the bibliography used to help generate this presentation, some very good engineering textbooks to refer to for further information. I hope this presentation has been of help to you, and thank you for viewing.